Hi, fifth grade. Today we're going to work on some math, so make sure you grab your fifth grade math packet. Get this guy out. And today we're going to continue working in day 7. We're going to be on this page for day 7, and we're going to work on numbers 3 and 4. We're going to continue to work with fractions and decimals. We're comparing fractions and decimals. So let's begin. Day 7, question 3. Order the numbers from greatest to least. We've got some numbers here, we have some fractions, and we have some decimals, and we need to put them in order. Our first step here is to kind of look at each number and see what we notice. The first thing I notice is that they all have the same whole number, 3. So we know all of these numbers are going to fit in between the whole number 3 and the whole number 4. So now what else do I notice? Do I see any that are way less than half or way more than half? What do you guys think? Well, I first notice 3 and 1/5. 3 and 1/5, 1 out of 5, is well below a half. So I'm just going to kind of write that over here so that I know it's at least below the halfway mark. Then I got to 3.4. That, in my mind, is very close to a half. That's like saying I've got $3.40, and if I get to $3.50, that's right in the middle of 3 and 4. So I'm going to kind of write that guy right beside my halfway mark, which is right here. Next, I have 3 and 7/8. Let's think about this one. 3 wholes, and then if I have eaten 7 out of the 8 slices, I've eaten almost all of the pizza. So that is almost to the 4. If I eat one more slice of pizza, I have a whole number 4. So again, I'm going to write that pretty near my whole number 4. And finally, I have 3.031, or 3 and 31 thousandths. So out of 1,000, I've only got 31. If you were to round this decimal right here to try and make it look sort of like money, you would look at the hundredths place and then look next door, and you would end up getting $3.03. That 3 cents, that's nowhere near another full dollar, is it? So I know that that number is real close to the whole number 3. However, so I've kind of ordered them now, haven't I? But I need to check and make sure they're in the correct order. So I really need to turn them all into decimals. The two numbers that aren't decimals are the 3 and 1/5 and the 3 and 7/8. So we know fractions are a division problem. I've written them over here, and we're going to go through them together. So for 1/5, I've written it as the division problem. Can 5 fit into 1? No, so I need to make that one look larger for now. So if I add a decimal here and then a 0, I haven't really lost any places. Carry that decimal up. Now I have 5 into 10, which I know 5 times 2 is 10. So 2 times 5 is 10. Bring that down. Subtract. I've got a 0, so I'm done here. So turning this into a decimal, I have 3.2. And again, I like to look at it like money. It's easy for me to put it in order if it's like money. So I got $3, which they all have $3.20. So I know that that's smaller than $3.40, and I know that it's bigger than $3.03. So far I'm kind of right down here. I've got the $3.03, that's the smallest. I've got the 3 and 1/5, which was our $3.20, which comes next, and then I've got the $3.40, or 3 and 4/10. Now let's triple check about this 3 7/8. We're going to turn it into a division problem again. 8 cannot fit into 7, so I add that decimal, add another 0, carry the decimal. So now 8 into 70. This is when our multiplication facts really come in handy. If I think through the multiples of 8, I end up going to 64 without going over 70. So 8 times 8 is 64. I'm going to subtract here. I end up with 6. I'm running out of room. I'm going to add another 0. Bring that down. Whew. So now I need 8 into 60. Again, my 8 multiplication facts. Really important for us to be practicing those. If I keep going through my 8 multiples, I end up with 8 times 7 is 56. So then I'm going to subtract again and get a 4. Can't really fit it, but I'm adding another 0. Whew. I'm bringing it down. And I'm excited because, that's right, I'm excited because I can see that 8 goes into 40. I know my 8 multiplication facts, and I know that 8 times 5, I'm going to rewrite this real quick. So I had 0.87, and then 8 goes into 45 times. 5 times 8 is 40, and I know 40 minus 40 is 0, so I'm done. So this shows me that 3 7/8 is 3.875. So if I look at my tenths place, I've got 3.8. So I've got 3.03, 3.2, 3.4, and then this is 3.8 or 875. If I were to round this to look at it like money, it would end up being $3.87 or $3.88. So my order is 3 31/1000, 3 1/5, 3 4/10, and 3 7/8. Day 7, question 4. Choose the symbol less than, greater than, or equal to that correctly completes each expression. So we've got 3 different questions here. We are comparing a fraction to a decimal each time. So what we need to do is turn them all into decimals so we can really see and compare. Our first fraction here says 1 5/10. 1 5/10. Well, this one, I could turn this into a division problem, but when I say 5/10, it makes me think, how do I write 5/10? How in the world do I write 5/10? See if you can write it on your paper in front of you. Let's see. I've got 1 5/10. 1 5/10. I've put my 5 in the tenths place. So now I know that I'm comparing 1 5/10 to 1 57/100. If I look at it like money, I've got $1.50 over here. I've got $1.57 over here. Which is larger? You're right. I have 7 more cents over there. Our next question says 4.75 and 4 1/4. So I'm going to turn this 1/4 into a division problem. But before we do that, let's remember what our fourths remind us of. It has something to do with money again. If we broke up $1 into 4 equal coins, what kind of coins am I using here? If you said quarters, you're correct. So if I have 1 quarter, it's 25 cents. Another quarter, or 2 out of the 4 quarters, would be 50 cents. Another quarter, 3 out of the 4 quarters, would be 75 cents. And if I add that final quarter, 4 out of 4, or 4/4, I've gotten to a whole dollar. So 1 out of the 4 quarters, 1/4, is 25 cents. 0.25. Over here it says 0.75. How many quarters is that? You're right, it's 3/4. So I'm comparing 3/4 to 1/4. Now let's check. 4 goes into 1, can't do that. Add the decimal and 0. 4 into 10, well, if I skip count by 4s, I get 2 times 4, and that ends up being 8. If I subtract, I get 2. And then I'm going to add another 0 to bring down, since I haven't gotten a 0 down here yet. So now I have 4 into 20. Well, if I skip count my 4s, I got 4, 8, 12, 16, and then 20. So 5 times 4 is 20. Subtract, get a 0. So I was correct. My 1/4, or 1/4 of a dollar, is 0.25. So I'm comparing 4.75, or 4 3/4, to 4.25, or 4 1/4. So I can tell that this guy is larger. My next one, I have 3/50ths compared to 60/100ths. Now, let's see what we can do here. I'm going to turn my 30/50ths into a division problem. I know that 50 cannot fit into 30, so I need to add that 0, add the decimal, bring that decimal up. So now 50 into 300. Can I skip count by 50s? Well, it's kind of like skip counting by 5s, but we're just adding a 0. So 50, 100, 150, 200, 250, 300. Let's do that together. Start with 50. 50 times 1. 50 times 2. 50 times 3. 50 times 4. 50 times 5. And 50 times 6. So I hit 300 right on the dot. So I know it is 6. And 6 times 50 is 300. Just like 6 times 5 is 30. So then if I subtract, I get 0. So I've turned 30/50ths into 6/10ths compared to 60/100ths. You know, that looks mighty familiar. You know, if I just add a 0 here, they're exactly the same. Or if I just get rid of this placeholder 0 and get rid of this placeholder 0, they're still exactly the same because they both equal 6/10ths, or 60/100ths.